So there's going to be some derivatives which we're going to encounter, which are going to be a little bit complicated to differentiate. And typically these are the ones where we run into this product situation, where we have the product of two functions. Okay, so here again we have the product. How do we differentiate? How do these two functions interact with each other? Because essentially we're saying, how does these two functions change relative to each other? Well, this one's going to have some kind of change, this one's going to have some kind of change, but they will have to interact somehow. And we're going to look at how these interact in a bit, but essentially there's a rule for this. It's called the product rule. So when we have two functions being multiplied together, we have f of x times g of x. We're going to differentiate the first function and times it by the second function undifferentiated. And then we're going to add that to the first function times the second function differentiated. Okay, so we'll show you just how this works first, and then we'll explain why this happens. Okay, so again, here's this product. Well, we could use the power rule here, and we can just differentiate 1 over x. But when we differentiate this, we can't just simply go 2x times 1 over x like this. Okay? Because we're not accounting for how do these two functions, how do their changes interact with each other. We're just saying that this one changes this way, this one changes that way. Okay? We're just going to times them together. Well, that's not exactly how it works. In fact, it doesn't work like that. So we have to apply this rule. Okay? So this rule looks like this. So the derivative, we're just going to say y prime is equal to, okay, we're going to differentiate the first function, and then we're going to times it by the second function. Okay, this is log x. Okay, notice I didn't differentiate the second function. Plus, we're going to leave the first function undifferentiated. So x squared plus 2. And then we differentiate the second function. Okay, and essentially that's it. Now we could simplify this. Okay, there's really not much need to simplify this unless it's going to give us some nice looking expression. But there it is. There's our product rule. And this is how we differentiate products. And we cannot just, it's not like when we add functions together where we're just changing the y values and we're saying, well, the change in this y plus the change in this y, we can just add them together. This is different because these two functions are now interacting with multiplication. So here we have another one. Okay, this is a derivative of 2 sine x cosine. Some of you may have recognized this as actually a trig identity, but we don't need to treat it as trig identity. We can just differentiate it using their product rule. Okay, so the derivative y prime is equal to derivative y prime. Okay, if I apply my rule, it's going to look like this. So here's my first function, and here's my second function. Okay, these two functions are interacting as a multiplication. So the 2 has no effect on the derivative. I'm going to differentiate the sign and end up with cosine x. Okay, I'm going to leave the second function undifferentiated, so we get cos x plus, okay, so I'm going to put this in brackets here, plus, I'm going to leave the first function undifferentiated, okay, and then I need to multiply that by the derivative of the second function, which is negative sine x. Okay, so there it is. There's our trig function. There's our function differentiated. Now I can simplify this. Okay, so y prime is equal to 2. Well, this ends up being cos squared x minus sine squared x, which itself is a trig identity. So this is actually a trig identity. This is a trig identity. And we could just leave it like this. However, I'm just going to down here a little bit lower using a trig ID. We end up with y prime equals 2, and that's actually cosine 2x. Okay. Well, you may have noticed there's actually a trig identity over here as well. Okay, so what if we apply the trig identity here? Okay, if we apply the trig identity, really we're saying we want the derivative of sine of 2x. Well, actually, this is actually a much simpler function because we can see that's a horizontal compression of one function, and we don't have two functions interacting with each other. Okay, and we don't have to do this complicated interaction, which was necessary for a product. And if we differentiate this, we get y prime is equal to, well, derivative of sinus cos, and we apply the compression factor adjustment times 2, and notice that we actually get the exact same as this. So this interaction, this more complex interaction of the two functions actually is important. It's necessary to get the correct answer. Okay, we can't just simply differentiate this and multiply those two derivatives together. That is not how functions will interact with each other.